Hey everyone, and welcome back. Today we're going to tackle a question that sounds super simple, but is actually incredibly complex. How do you measure a ship? And it's not just about whipping out a giant tape measure, because in the world of shipbuilding, every single dimension tells its own unique and vital story. So let me just ask you this straight up. If someone pointed to a massive ship and asked, hey, how big is that thing? What would you even say? Would you talk about how long it is, how tall, how much it can carry? Well, the truth is, there are a whole bunch of right answers. I mean, just look at this thing. For a complex piece of engineering like a modern container ship, a single number just doesn't cut it. Its size is really a collection of very specific, very important measurements, and each one is crucial for a different reason, from making sure it can actually dock safely in port to just surviving a monster storm in the middle of the ocean. And that's exactly what we're going to get into. We're going to break down the key dimensions of a ship, because once you understand each one, you start to see a unique part of its design, its purpose, and its life out at sea. All right, let's jump right in. First up, length. Seems simple enough, right? But here's the thing. Even with something this basic, there are two critical measurements that are used for completely different reasons. It all depends on who's asking the question and why. The first one, and probably the one you're thinking of, is length overall. We just call it LOA. It's exactly what it sounds like, the absolute total length of the ship from the tippy top of its bow to the very end of its stern. One big number, no confusion. So why does this one number matter so much? Well, the LOA is everything to a port captain or a harbor master. This is the number they care about. Is the ship going to fit in the dock? What are the clearances? LOA is a logistics number, pure and simple. But then we've got this other measurement, length between perpendiculars, or LBP. And this one's way more technical. Basically, it's the ship's length measured right at the waterline, where the ship actually sits in the water when it's fully loaded up. It's measured from the front of the bow to the post where the rudder pivots. So you see, the LBP, that's not for the folks at the port. Nope, that number is for the naval architects, the people who actually design the ship. This is a fundamental design number. They use it in all the critical calculations for the ship's stability, how it moves through the water, and its structural strength. It tells the engineer how the ship is going to behave. Okay, so that's length. What about how wide a ship is? We called it the beam, and yeah, you guessed it, it's not as simple as one number either. We have to ask, are we talking about the space inside or the total footprint on the outside? So this brings us to two key ideas, molded breadth versus extreme breadth. Think of it like this. Molded breadth is the width of the ship's skeleton, the internal structural width before you add the outer steel skin. Extreme breadth? That's the total width, skin and all. And this cross-section right here, it shows you that difference perfectly. The molded breadth is all about internal volume, but that extreme breadth is what matters when you're trying to squeeze through a narrow canal or fit into a dry dock. A few inches of steel plating can make all the difference. All right, let's talk about the vertical dimensions. This is all about how the ship sits in the water. And trust me, these measurements are absolutely critical for staying safe and, well, not running aground. This single image right here is awesome because it tells the whole vertical story. You can see the waterline, what's underwater, what's above it, and from this one picture, we can pull out three super important numbers. Okay, so first up we have draft. That's how deep the ship is sitting in the water, from the waterline down to the very bottom. Then you've got freeboard. That's the opposite, from the water up to the main deck. Think of it as your safety buffer from the waves. And finally, air draft. That's the whole shebang, from the water all the way up to the highest point on the ship. And let me tell you, that air draft, it is a huge deal. That's the one number that tells a captain whether they can actually fit under a bridge or not. Seriously, they'll have to time the tides, wait for hours, just for a few extra feet of clearance. It's a constant game of inches. So we've covered the big, obvious lines, length, width, height, but now we get to the really cool part. The art of shipbuilding, it's all in the curves. This is the hidden geometry that keeps a ship strong, stable, and efficient. Okay, check these out. First you have camber. See that slight curve in the deck from side to side? That's it. Then there's shear, which is the curve of the deck from the middle up towards the front and back. And these aren't just for looks, not at all. They add a ton of strength and, really importantly, they help shed water when a massive wave crashes over the deck. And then there's this really cool one called tumble home. This is when the sides of the ship actually curve inward as they go up from the waterline. You see it a lot on old warships. It was designed to cut weight up high and has a big impact on a ship's stability and how it recovers from a big roll. And finally, let's look at the very bottom of the hull. This is called the rise of floor, or sometimes dead rise. It's basically the angle of the ship's bottom. Is it more of a V shape, or is it flat? That single angle makes a massive difference in how the ship handles, especially when the weather gets rough. Okay, wow. So we've looked at all these different pieces, right? From the tip to tail length to the tiniest curve on the deck. So what's the big picture? This little table really brings it home. You've got the dimension, what it is, and the so what, why it actually matters. LOA, that's for docking. Air draft, for getting under bridges. The draft below the water, that's for not getting stuck in shallow water. And LBP, that technical one, that's for the engineers, making sure the whole thing doesn't, tip over. So you see, a ship's size isn't just one number. It's this incredible, complex puzzle made of thousands of precise measurements. Every single piece has a job to do, and they all have to fit together perfectly to keep that ship safe, stable, and doing its job out there on the ocean. And that brings us to one last kind of sobering thought. A ship is this masterpiece of precision. But what happens out there in the middle of a storm when just one of those thousands of measurements is off by just a little bit?